the concern. Now, the automatic workload repository is a way of for the system to keep track of how well it's doing in terms of performance, basically. So every second, the system will take a snapshot of executing SQL, and all this is written to a data file somewhere. Now, SQL that takes a long time to execute is obviously going to get, more noticed and end up in these tables more than others. So, for example, as I already said, if someone's injecting UTL HTTP request to exfiltrate data somehow, because there's a network round trip involved in that, that's going to take a long time. So we'll find entries in these tables, essentially, that record in its entirety the select statement. So one way we could do this in the automatic workload repository is combine the stats with the text and dump basically all the SQL text there. There should be another one. Here we can get the... no, that's not it. Sorry, I was missing a slide there. Which query is it? This one here you can use obviously to dump information about a given user ID that's performed a certain query. Let me put it in Notepad so you can see it clearer. So you can see here we're specifying the user ID. We're interested. Let's say the user account with that user ID we think it's been compromised. We can basically go through these things looking for actions that they may or may not have taken. So let's do this. So you can see we're dumping out select statements here. So, funny enough, the statement we've just run is now in the, because it took a long time, it's now in there, So we can see an update has taken place and, some trigger thing has taken place. Now, we can also actually, we'll come back to that later. Suffice it to say that the automatic workload repository is an extremely useful source of information. The $SQL view is what's known as a fixed view. These fixed views are basically in-memory resident. So when the database is shut down, it's gone. So if your company policy is such that in the event of a compromise, unplug from the network, shut the system down, you might be losing potentially valuable evidence. One of the interesting problems, actually, with the whole live response thing is in Britain we have what's known as ACPO. It's the Association of Chief Police Officers. And they wrote some guidelines on how to do a forensic analysis. And, they basically say you're supposed to go and photograph the screen, and if the screen's turned on, and barely touch the mouse and shut the system down, pull the cables out and everything like that. Well, that, it's clearly been written with the guidelines for performing a forensic analysis of, a potential criminal. You boot their door down, you go and grab their PC and what you should do and everything like that in terms of maintaining evidence. I don't think it was ever intended to be guidelines for the compromise of an Oracle database server in the back end of nowhere. So the legal question is, if you're performing a live response on a compromised database server, is that going to invalidate any evidence? Is that going to make it impossible to pursue criminal charges? I don't know the answer to that. Does anybody know the answer?
As long as you can reproduce what you do,
You don't think so? But surely, because it's a live response, you are in some way modifying it,
Right.
modifying the system.
You don't modify the system, but if you can document how you modify it.
Yeah. Okay, that's what I thought, but without having, are you a lawyer or I'm just wondering that, if that's your opinion or whether it's,
Well, it's the same thing if I'm doing a hard disk now.
right.
If I could document what I did, then
But in terms of a live response, you wouldn't be doing a live response on a hard disk, surely? Yeah, sure. Okay. It's just I've been mailing out to lawyers and ACPO, and they don't want to seem to talk to me. Don't know why. But yeah, it would be really good to get an actual legal answer to this question. I'm sorry? Sorry? Dump the physical memory. Sure. So I completely concur. I published a paper a couple of months ago called Live Response that deals with, what to do with a database server. And, one of the things is obviously dumping physical memory there. What's interesting in that, of course, is though that one of Joanna's recent talks was defeating hardware-based RAM acquisition tools and everything like that. And I don't know if you ever saw that talk. I'm not sure if the slides are available, but it looks quite interesting. Anyway, that's an aside. No, but if you've got a compromised server and someone does hardware-based RAM acquisition, how do you know that someone hasn't loaded up that kind of thing into the database server? So I'm just saying it's like there's always it's always an arms race, isn't it? Someone comes up with a new idea and then someone defeats it and so on, kind of thing. So okay. So the SQL text is a fixed view in memory, and of course, we can get this from a memory dump and so on. Or if we're doing a live response, then we, in a very controlled fashion, and of course documenting the way we do this, connect with for example, we could connect with SQL+, having reviewed glogin.sql and those SQL things that run in the background, of course. And we can simply dump the data from memory that way. So, just as an example of this. So we can go, and this here is dumping the name of the user that executed the SQL, and the parsing ID and the parsing schema ID. So again, if these things don't match, if for example there's an entry in there with the parsing user as Scott and the schema as sys, that might be indicative of a SQL injection attack. It might also be, of course, indicative of someone going alter session set current schema, and changing the schema. But we spoke about live response and taking actions that actually modify itself. You can see now that the previous query we run to get access from the automatic workload repository is now listed in here. So actions we take are now overwriting stuff in the $SQL. It's like a circular buffer, basically. As new stuff comes in, the older stuff gets bumped out. So if you're doing a live response, the very first queries you should run are, select from this view, select from the automatic work repository, and so on. So you're not influencing too much. You're not bumping out too much stuff. And then you can go on and do, dump the other information with regards to, users, object IDs, object names, and so on. So this actually brings us to the end of the presentation. Obviously, in review, all we've done essentially here is looked at the data files, specifically the metadata themselves, ways of getting access, information from the redo logs, and looking at things like the system monitor tables to access information about selects, and also the automatic workload repository. So there are other places where evidence can be found, of course, the TNS log files, trace files, and so on. So that we'll save for next year, I suppose. Are there any questions regarding this stuff at all? Tim, you're always good for a question.
I have a valid one, actually.
All right, cool.
The SQL select statement as resident in memory.
Sure.
Do you have any insight into how deep, how far back in history?
Well, it depends on how many queries are being run. There's usually about 1,000 queries in the buffer. Now, obviously, a anti-forensic attack on this would be one of the last things an attacker does is fires off 1,000 queries. That's obviously going to bump out, his real attack. So it might be select, 1 from Joule, select 2 from Joule, select 3 from Joule, or whatever. So each one's different and going to get a new entry in the in the $, SQL fixed view. So in terms of an anti-forensic attack, you can wipe your stuff. In terms of an anti-forensic attack actually against the redo log, if you've got DBA privileges, you can just alter the system and completely delete the redo logs and everything like that. So
You need to have access to that pretty quickly after an attack.
sure, but in terms of the anti-forensics attacks, there are definitely attacks that are possible that make it harder, and then you've got to just, work a little harder to get the evidence back. Because obviously when you wipe a file, supposedly, you can still get that information back off again and everything like that. Or if you delete it off the file system, then it's still going to be there. Sure?
Your presentation focused the deletion of the road.
Yep.
Would these techniques still apply just on the modification of rows as well?
Sure. So if you update a row, what typically happens is, depending upon which elements, which columns of the row you're updating, if it's numeric, it usually stays in the same row. But if it's like string-based, then what will happen is you'll get a new row being added to the top and the old one sort of invalidated. So yes, if it's being updated, then you can still get evidence out. It's done in a slightly different fashion. And of course, if they're not dropping the objects, they're just creating them, then that's when the presence of the DBA comes in useful, because he can say, wait a minute, what's this my temp table? Or what's this get DBA function, So, sure? I'm sorry? Yeah. Very well could do, I don't know. But that's an excellent place to start looking. And also the undo table space, of course, is another place where, that's good for evidence too. Sure?
Even table spaces where the rows are either deleted or updated or modified, it seems to me like that would be at least partially susceptible to coalesce table space. Is there anything that is completely inviolate, at least at the time of the presentation?
I don't know. So here's the thing. If you Google Oracle Forensics, there is so little information out there, and I mean, Paul Wright, one of my colleagues, posted a paper a couple of years ago, but it's completely under research, and all these things like that,